Good evening, everyone. My name is Guled Mumin, and today I will presenting on a penetration test using Kioptrix 1 virtual machine. In this presentation, I will guide you through the enumeration and vulnerability analysis I conducted using Nmap and the flow hypothesis methodology. My objective is to demonstrate how we can systematically identify the open boards, surfaces, and vulnerabilities within the system, then hypothesize how this flow can be exploited by potential attackers. We will also cover the steps involved with scanning with the Nmap, identifying vulnerabilities, and analyzing the results using structured methodologies. By the end of this presentation, you will have better understanding of how penetration testers evaluate the security of the system, prioritize the risks, and apply the necessary countermeasures to protect them. I hope this session helps you deepen your understanding of ethical hacking techniques and provides useful insights into Kioptrix 1 environment. Let's get started. Okay, let's see what's the Kioptrix level 1. The Kioptrix level 1 is a series of vulnerable virtual machine specifically designed for the penetration testing and ethical hacking training. Secondly, in this slide, we are going to introduce you the concept of enumeration and the process of vulnerability analysis that I conducted during our Nmap scan of the Kioptrix virtual machine. Enumeration is the process of identifying open ports, surfaces, and potential entry points on a system. And it is first critical step in assessing security posture. We will also take a closer look at the steps we follow to identify, validate, and prioritize potential risk, ensuring a structure and through the vulnerability analysis. Okay, our first step was to check if the target machine was online using Nmap pin scan. This provides basic connectivity information, confirming the target availability, and also we can see all open ports are listed in this screenshot. Okay, in this step, we use a Nmap powerful network scanning tool to enumerate the target machine. The command we executed is shown here. Let's break it down. -T4 option speeds up the scan while keeping it reliable. We focus specific ports SSH secure shell, port 22 and HTTP port 80 and RPC port 111 and NetBIOS 139 and HTTPS 443 and the ports of 32,768 which might be used by certain services, and -VV flag gives us a detailed output during the scan, making it easier to analyze the result. By running this command, we get a critical information about the target, which will help us map vulnerabilities and plan further exploitation. Okay, to quickly determine if the target system has a port 443 open, we use the focus in Nmap. This command checks only port 443, which is used for secure web traffic over the HTTPS. Okay, by using the open flag, we filtered out closed ports showing only relevant results. The -T4 option speeds up the scan, making it ideal for quick reconnaissance. If the port 443 is open, we can proceed with the further analysis, such as checking for secure second layer and TLS transport layer secure vulnerabilities or misconfiguration. Based on the result of the scan, I hypothesized that the certain surfaces might be misconfigured, leaving the system vulnerable to attack. For example, open ports with outdated surface could allow attackers to exploit these weaknesses. This diagram illustrates the typical attack but used by the hackers. The process of started with the Nmap scan, where the attackers discovers open ports and running surfaces. When they identify the outdated or vulnerable surfaces, they move to exploitation phase. For example, if the attacker finds an outdated Apache web server on the board's AD, they might attempt the directory traversal attack to access the restricted files. Similarly, if the an old Samba version is detected on the board T139, they could use known exploit like MS08-067 to gain remote code execution. Once inside, the attacker seeks privilege escalation, gaining root or administrated access to take a full control of the system. From there, they can move literally across the network and accessing other services and sensitive information. At the final stage, they might exfiltrate data, deploy malware, or disrupt these services depending on their intent. Preventing this attack but requires patching vulnerabilities, restricting access, and monitoring network activity. Okay, after researching the flaws, I identified two major issues. The first one is related to surface running an outdated surface, which is known to have a specific vulnerability. The second flaw involves misconfiguration in the secure shell surface that could allow unauthorized access if the weak passwords are used. Okay, in my conclusion, this Nmap scan has emphasized the importance of proactive vulnerability scanning and risk assessment. By identifying the vulnerabilities and applying the appropriate security measures, organizations can mitigate potential threats and reduce the risk of compromise. Effective vulnerability management is a key to maintain a secure system. And regular batching, access control, and monitoring are essential practices to minimize the security risks. That's all what I have in my video today. Thanks for watching and have a good one.